Welcome back to C++ with Miyoshi. Today we're going to talk a little bit about something called identifiers. Those are generally, they are constants or variables. Just like in math, a constant is something that doesn't change and a variable is something that can change. I have over here a little picture that I like to use. It's a little rectangles. These rectangles represent memory locations. They aren't any specific size, but they represent memory locations that we use in the computer. Anyway. So, the different types of variables you can have, or different types of constants you can have, and that's one of those vocabulary words I talked about earlier. Data types, we have two different data types we can have. There's many different data types, but there's integer data types and floating point data types. There are other data types too, but these are the ones we're going to work with in the beginning. The integer data types, we have int, int. In the old days there was a long, they were just actually bigger integers. Chars and booleans. The thing about integer data types is they don't hold any decimal places. There's no fractional parts. There's not 3.14159. There's just a 3 or whatever happens to be. They are integers just like you have in your math classes. Floating point data types. There are the other integer data types are char and bool. Char holds character data. Actually, it just holds integers that get represented or that represent a character, and the character can get output for you. And a bool is a data type that just stands for Boolean, and all it holds is trues and falses. A true or a false rather. Zero is a true, a zero is a false, and 1 is a true. And you can use them just like integers, at least in C++. Floating point data types, they can hold our fractional parts of our numbers, so they are things like pi, 3.14159, whatever it happens to be after that. But they are, our floating point data types are float, doubles, and back in the old days there was a thing called long doubles. If you need something bigger than a double, you could do a long double. Although nowadays compilers are big enough, they have enough memory. Computers have enough memory that you can hold bigger data types with more space. To use data types, you're going to have something like this. You're going to have a type, and then your name, or variable name, or constant name, and then you have this semicolon. Or you have something like your type, and then your name, and then this little equal sign. An equal sign in C++, a single equal sign, we're going to read as is assigned the value. And then we have our value, and then we have our semicolon. This would be declaring our variable, and this over here would be declaring and initializing. When you see this assign the value, and the value after it, that gives it a value and sticks it over here in my memory location. Okay? So, here's a couple examples. There are some naming conventions you must follow. Every variable name or every constant name, every identifier name must start with either a letter or an underscore. After that, you can have either letters, underscore, or numbers. There's no special characters in there. There's no pounds or no minus sign or dashes or minuses. You can only use letters, underscores, and numbers. And that makes it so that there's not any confusion on your data type or on your variable names. So here's a couple examples. I have int a, and that's just int a semicolon, and that's just declaring my variable. Again, what it does is it sets aside memory location over there in my computer. Int b is assigned the value 3. That's declaring and initializing. Oh, by the way, when I say int b is assigned the value 3, that really means it means that the memory location associated with b is assigned the value 3. But we just say int b is assigned the value 3. But it really, like I said, it means the memory location associated with b is assigned the value 3. Okay? Here's a little different one. We have const in front of it. It's just the same as I have here with these guys. This happens to be a const float. C is assigned the value 3e8. There's a couple things going on here. First of all, const means that it's a constant. It can't be changed once I declare it and initialize it. By the way, on constants, you must initialize it as well as declare it. You can't just initialize it without the assign the value like I have up here with the a. I must give it a value. If I don't do that, the compiler will I like to say puke up all over you, but what it does is it just says, it gives you a bunch of errors and says, sorry, you can't do that, you got to initialize it first. Then we have this float. D6, again, this shows you that it starts with a letter and has a number in it as well, and it has a decimal value in it. Now, the difference between these different data types, they just, as how big they are anymore. It used to be that the longs were bigger than ints, but now an int is big enough that you can hold large values in it. Again, there's no decimal points in them. If you have some number that's larger than what your compiler can store in it, then you're going to have to use a float or a double. And the difference between the double and the float is just the precision value, how many decimal places you can hold behind them. One other thing that I would suggest you do as you name your variables, try to name them something that makes sense for your program. Here we just have A, B, C, and D. D6 for our variable names. That's kind of a habit I've gotten into from programming a long time ago. And when there wasn't as much memory, but nowadays there's so much memory, you may as well have variable names that make sense. Also, the programs are getting larger and larger. You're working in groups of people to program, and so you want to make sure that you and other people can read and understand what your variables really mean. So, variables and constants, they're called identifiers. Use them in your programs. You're going to need them in your programs because who wants just a program that just outputs stuff to the screen? That's not very useful. I'm going to show you how to get these guys out to the screen next, and then we'll go from there. We'll do a little bit of calculations and doing things a little bit more exciting than just outputting to the screen or just holding variable data and variable and constant data. So, thanks for tuning in, and hopefully come back for more C++ with Miyoshi.